name is Minh. My team consists of Jeremy Lapato, Morsy, and Douglas Burtner, and we were supervised by Dr. Mark and Dr. Caps. For our project, we were assigned to design a hardware platform to support software-defined radio. Software-defined radio is similar to analog radio in that it is a radio communication system. The difference is that while analog radios will use hardware components, digital software-defined radio will instead implement those components using digital software. And a field programmable gate array, also known as an FPGA, is a board that can be programmed on the spot by the designer to fit any number of purposes using Verilog or VHDL. The benefits of these technologies is that a software-defined radio will drastically reduce the need for hardware. An FPGA can take the role of several different hardware components at the same time. So the goal of our project is to combine these two technologies and create a single package that can easily be implemented by users. Our approach to this project is to first take a basic Spartan 3 FPGA and create an add-on board that could expand its signal processing capabilities. We would then implement a graphical user interface that would call up from GMU software and different functions that would demonstrate these capabilities. With that in mind, the goals of this design then are to interface with the Spartan 3 FPGA and our GUI interface. We want to show that it is capable of receiving and transmitting radio signals. And we want to successfully implement these the functions of an SDR oscilloscope, spectrum analyzer, and a function generator. Our GUI, we intend to have it implement these designs and be easily accessible to a user who does not quite understand how to navigate Linux or any other GNU software. We also hope to emulate the performance of products that already exist, such as the Edis Research USRP. We also hoped that the design would be easily expandable and that it would minimize costs so that it can compete with existing products. And now I'll let Jeremy describe our hardware.
As Minh said, my name is Jeremy Lapato, and I'll be going over the hardware portion of our project for you today. First of all, the design requirements for our hardware for this project were we need to be able to create a system that is going to be emulating the Edis Research Universal Software Radio Peripheral, the USRP. We want to use the platform of the Digilent Spartan 3E starter board. The reason we wanted to do this was because this is a readily available, commonly available, and relatively cheap FPGA board that has a lot of functionality to it, but we just want to expand on that so that maybe users in the educational field who already have access to this can very inexpensively add a small add-on board and all of a sudden have a software radio that can emulate the capabilities of the Edis USRP at a much lower cost when they already have the other board available to them. Things that go into that, we must modify the existing firmware so that it will be implemented on a Xilinx Spartan 3 FPGA. It's currently tailored for a Altera Cyclone FPGA, so there's some modifications and some code changes that would have to happen there. The last requirement for our project was that the PCB that we create would be compatible with the Edis Research daughter boards so that, once again, instead of trying to recreate something that already exists, you can take these Edis Research boards, add them onto our system, and once again, you're emulating the USRP without the extra cost of the main board itself. So our approach to this, there are two things that we considered in our approach. One is sustainability and two is cost. Both of these things are big factors for the consumer market. Sustainability, nobody wants to buy something that is going to be out of date a year later, a year and a half later, half a year later. So we want something that's going to be able to be expanded easily and very inexpensive so that this can continue on without needing to be directly replaced anytime in the near future. In addition to that, we want to keep the cost low. We realize this is something that people want to get. They don't want to pay $700 for it because then they can just get the Edis Research Board that's already existing. This is meant to be something that would come at a cheaper price to add on to a board that they already have and give similar functionality. So those were our two main design goals from our side. A little bit about the hardware itself. The design features, it's a simple interface to the Spartan 3D board made by Digilent. As you can see in the picture here, the main board on the left is the Digilent board. You can see at this part right here, this is the board that we designed, and then the daughter card from Edis Research is attached on top of it. It's a simple plug-in right there. You can see even on our board that we designed, it's very limited circuitry. This is to reduce costs. We try to get inexpensive materials, but that would still provide a similar functionality to those that are used on the Edis Research Board. Also, another description, we need to be able to interface with both the transmit and receive cards. This one that we show on there is the receive card. This lower port down at the bottom is for a transmit port as well.